Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everyone? I hope everyone is doing good by the mercy of Almighty Allah. Welcome again to my channel, Little Learning with Sadman Sir. And in today's video, we are going to discuss about buoyancy. Now, buoyancy is something that we all have experienced at some point in our life. I will give you an example. Like we play with football, right? So if we try to submerge that football in a bucket of water, or let us say in a pond, then we have to apply force on it in the downward direction. Now, after submerging it into the water, what will happen? If you remove the force, if you remove your hand from it, then what will happen? The football will come up, right? Now, why this is happening? This goes to show that the liquid is exerting some force in the upward direction on the object, right? Now, that is what is actually buoyancy. Okay. Now, let us take a look at the definition. The upward resultant force on a partially or fully submerged body in a fluid is called buoyancy. Now, before I discuss further about the topic, I want to clear up two concepts. One is fluid. Fluid does not actually mean only liquid, okay? Many of us have this misconception that fluid means only liquid. No. Fluid actually consists of gas and liquid, okay? Now, how do we know this? Because the definition of fluid goes like this: anything that can flow. So, gas and liquid both can flow. For example, the river water, that can flow, right? So, liquid is fluid. And gas, for example, we can consider air. Air is also able to flow, right, from one place to another. So that is why gas is also included in the concept of fluid. Okay, so buoyancy will act in both gas and liquid. Okay, in liquid, I just gave you an example, but what about gas? Can you come up with an example? Pause the video and think for a couple of seconds and then see if you can come up with an idea. I will give you the example now. The example is parachute. Okay, using the buoyancy, the parachute works. Okay, that is why it takes a little bit more time to come to the ground. Okay, now for this level, we will actually focus on buoyancy of the liquid. Okay, so that is first thing. And then resultant force. What do we mean by resultant force? Let us say we have an object here, and on this object we are exerting two force. One is in this direction, let us say it is 10 Newton, and another force in the opposite direction, that is 7 Newton. Now, if I ask you, what will be the resultant force acting on the body? Can you tell me? I know many of you will come up with the correct answer. That is, the resultant force will act in this direction, and the value of resultant force will be 3 Newton. Now, the question is, how did you find this? First of all, if you talk about the direction, obviously the direction will be same as the direction of the larger force, right? 7 Newton and 10 Newton. 10 Newton is larger. So the resultant force will be in that direction. And 3 Newton, how we got it? By subtracting 7 Newton from 10 Newton. 10 minus 7 has given us 3 Newton. So to get the value of resultant force, what we did? We subtracted the smaller force from the larger force. Okay. So this is how the resultant force is actually calculated. Now, why we are mentioning upward? How do we know that it will always be in the upward direction? Inshallah, through our discussion, we will get the idea about that. So let us say we have a jar full of water. Okay, it is full of the liquid. Now, if we submerge an rectangular object in it, what will happen? Yes, correct. So force will act on this object from all the direction. You can see from left, right, above and bottom, right? From all direction, the force is acting. So let us talk about the force that are being applied from left and right direction. These forces will actually be equal and opposite to each other. Okay, the force that will be applied on this surface will be equal to the force that is being applied from this surface. Now they are being applied in the opposite direction and of the same magnitude. So what will happen? They will balance each other. They will nullify each other, right? So as a result, on the resultant force, these forces that are applied on left and right surface of the object will have no effect, right? So we can, in our discussion, we can now ignore the force that are being applied on the left and right surface. We will talk about only the top surface and the bottom surface forces. Okay. So you might say that, okay, so the top surface forces and the bottom surface forces should also be equal to each other, and they should also balance each other. That actually does not happen. Why? We will try to take a look. For now, let us just admit that you can see that the arrow from the that is being applied on the top surface are smaller, and the arrow that are showing the forces that are being applied in the bottom surface are greater. That goes to show that the forces that will be applied in the upward direction is higher, and the forces that are being applied in the bottom downward direction are actually smaller. Now, why it is like that, inshallah, we will get to know a little bit later. So let us say the force that are being applied in the downward direction is F1, and the force that is being applied in the upward direction is F2. Now, if I ask you what will be the resultant force, remember this concept, okay? Now, the greater force in the upward direction, okay? That is why the resultant force will be in the upward direction, okay? And if I ask you what will be the value of resultant force, in that case, what we did, we subtracted the smaller force from the larger force, correct? So our equation, we will get to see a little bit later. Let us say the height of the object, it is h, and the depth of the top surface from the free surface of the liquid is h1, and the depth of the bottom surface of the object, okay, it is at h2 depth from the free surface of the liquid. So again, h is what? The height of the object, and then h1, that is the depth of the top surface of the liquid from the free surface of the liquid. Top surface of the solid object from the free surface of the liquid, okay? And h2 is the depth of the bottom surface of the solid from the free surface of the liquid, okay? Now, the resultant force, as I was saying, okay, it will be F2 minus F1. Why it will be F2 minus F1? Because we will subtract the smaller force from the larger force. Then we already know that from the equation of pressure, that is P is equal to F by A. So from here, if I cross multiply and try to develop an equation for F, I will get F equal to PA, right? So this F2 can be replaced by P2A, right? And F1, P1A. Now there might arise a question that I have considered in case of pressure P1, P2, but in case of area, why I did not consider A1, A2, why I kept the same? The answer is that the area on which the forces are being applied is same. You see the top surface, that is the area on which F1 is applied, and the surface on which the force F2 is being applied, both have the same area, okay? This surface has area A, and the bottom surface also will have the same area A. That is why area is same for both of them. Okay. Now, in our earlier videos, we proved that pressure inside a liquid, the equation for that is P equal to H rho G, right? Now, in case of P2 and P1, what can I write? See, P2 has been replaced by H2 rho Z, and A is as it is. P1 has been replaced by H1 rho Z. Now you might be thinking, why H2 and H1? Because P2 is the pressure that is being applied on the bottom surface. So whenever we are calculating the pressure applied on the bottom surface, we have to take the depth of the bottom surface. If you haven't watched my video on how to calculate the pressure inside a liquid, then I recommend you to watch that video first. That will help you to understand how I wrote P2 is equal to H2 rho Z. Okay, how I replace this, you will get to understand. The link will be given in the comment, in the description, inshallah. So from there you can watch it and then come back to this video and complete it. Okay, so now P1 is being applied on the top surface, so we will take the depth of the top surface. That is why P1 is H1 rho Z. Now another question might arise that why not rho 1, rho 2? G is same, that one we know, right? Because 9.8 meter per second square, that is the acceleration due to gravity, it's constant. But what about rho? It is the density of the liquid, correct? Okay, P equal to H rho Z. H represents depth and rho represents the density, okay, density of the liquid. So here the top surface, it is in a particular liquid, and the bottom surface is also in the same liquid, right? The liquid is not changing. In the whole pot, the same liquid is existing. So that is why we can consider rho same for both the top surface and the bottom surface. If the liquid is same, then the density is also same. Okay. Achha. Now, what we can do, rho GA, we can take it common, right? So if I take it common, then it will become, from here H2 will be left, and from here minus H1 will be left. Now H2 minus H1, with what I can replace it? Okay. Now take a look at this. H1 plus H. If I add these two, shouldn't they be equal to H2? Yeah. I will write it in this way. H1 plus H. It should be equal to H2. Now what I'm trying to find out? The expression for H2 minus H1. So H2 is here. Let us change the side of H1. Then H will be equal to H2 minus H1. Okay, so H2 minus H1, that gives us actually H, that is the height of the object. We can see it here also. H2 is the full depth. From here, if I subtract H1, then only H should be remaining. Okay, so you can understand from that way also. So H2 minus H1 has been replaced by H. So B equal to H rho GA. Now again, area and height, that should give us what? The volume, correct? Area into height. In our previous video, we have already discussed this. So area into height, that will give us the volume. So volume of what? Inshallah, we will discuss that a little bit later. Volume of the displaced liquid, but how it is displaced liquid, we will get to see. So for now, let us replace H and A by V, that is volume, and rho and G will be there. Now V into rho, that will be replaced by the mass M. How we can do this? Because from the concept of density, we know that rho equal to M by V. So M will be equal to rho V. Okay. So this rho into V, that will be replaced by mass M, and G is there. Now mg, it is weight. Now weight of what? That brings us back to the question that V is the volume, but volume of what? Okay. Now here the rho, what is rho? Rho is the density of the liquid. Density of liquid. Here V, it is the volume of displaced liquid. Why I'm saying displaced liquid? Because whenever we submerge an object in a liquid, what will happen? It will go and occupy some space, right? How much space it will occupy? And a space equal to its volume, right? If it is of larger volume, it will occupy more space, and if it is of smaller volume, then it will occupy less amount of space. Now, the amount of space that it will take, that amount of water will be displaced, right or wrong? For example, I will give you an easy example here. If that bucket is full of water, okay, so there is no space inside, no empty space inside. So when you submerge this liquid, what should happen? Not liquid, this object, what will happen? To give a space to this object, some liquid will be tripping over from this jar or pot, whatever we say. Okay, some liquid will fall from here. Now that liquid is called the displaced liquid. Let us say we have collected that liquid over here. Okay, so some liquid will be falling from here, and we have collected it here. Okay, just let us give blue color. Okay, even though water has no color. Okay, so let us say this is the water which has been displaced by this object. Okay, so this liquid will be called displaced liquid. Now what will be the volume of this liquid? This volume will be equal to the volume of the object. If the object has a smaller volume, then a small amount of water will be displaced. And if the object has larger volume, then larger amount of liquid will be displaced, right? Okay. So actually volume of displaced liquid, this can be replaced by the volume of submerged part of object, submerged part of object. Okay. So here you can see that volume of liquid, then density of liquid. So the weight we should get here, it should be weight of the displaced liquid, correct or not? Weight of displaced liquid. Okay. So that will bring us to the final line of our derivation. I will erase it so that it becomes easier for you to see. Okay. So from here, what we derived two things. Number one, the equation for buoyancy. Okay, that is B equal to V rho G. Using this one, we can find out the buoyancy, or sometimes we may use this equation also. Okay, for exam purpose, I will tell you which two equation to keep it in your mind. Okay, first one B equal to V rho G, and another one B equal to H2 minus H1 rho G A. And we must remember what each of them denote or represent. H2 is the depth of bottom surface from the free surface of liquid. H1, that is the depth of the top surface from the free surface of the liquid. Then rho is the density of the liquid. Please remember, do not put the density of object here. It is the density of liquid. Specially remember. Okay, I will write it here so that you can take note in your notebook. Density of liquid. Okay. And then G is acceleration due to gravity, and area, the surface area on which the force is actually acting. Okay. And this V represents the volume of the displaced liquid, but we can replace it with the volume of the object. Okay. If the full object has been submerged, then the volume of that object can be put here. We can use it here as the volume of displaced liquid. Okay. So if you are asked to calculate what is the weight of the displaced liquid, W, then also we can use this equation, right? Because they're equal to each other, D rho G. Okay. So from here, what I want you to learn mainly, that is buoyancy is equal to weight of the displaced liquid. And what is the equation to calculate that? V rho G. So if you want, you can calculate buoyancy using V rho G, or if you want, you can calculate the weight of the displaced liquid using V rho G. Okay. And this is very important for MCQ also. Buoyancy is equal to what? Buoyancy is equal to weight of the displaced liquid. Okay. Here they have mentioned fluid because it is mainly applicable for fluid actually. But here we have limited our discussion to liquid only. Okay. So today up to this much. If you have any doubt or any question regarding the topic or whatever we discussed today, then do not hesitate to get into contact with me. Write in the comment section. Inshallah, I will get back to you. Happy studying. Stay well. Assalamu alaikum wa rahmatullahi wa barakatuh. See you in future videos.